Hello everyone and welcome to our new unit on right angled triangles. In this topic we're going to be looking at a review of Pythagoras' theorem. In that we're just going to cover some Year 8 revision, pushing a little bit into Year 9 work thinking about three-dimensional Pythagorean problems. Then we're going to start looking at our introduction to formal trigonometry, learn how to find missing sides and lengths, angles, solve problems based on a real application, and look at pairings. So I'll get you to do a brainstorm in pairs. So pause the video now and do a brainstorm in pairs of everything that you can remember about right angled triangles, Pythagoras theorem, that sort of thing. Awesome. So hopefully you found out that you remembered a lot. In this section of work, we're going to just do a review of Pythagoras theorem, and we're hoping to know and understand how to remember what squares, roots, and the meaning of surds are, to recall Pythagoras theorem and how it works. Okay, so first up, what is the square of a number? Well, a square of a number is obviously something that's been multiplied by itself to give that number. So for example, if I have 3 squared, then that gives the square number 9. Okay, so we want to know all our square numbers, pretty much from 1 all the way up to 17. If you can go higher, that's good, but you want to memorize these. Okay, so we're thinking about 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 25, 36, etc. Okay, all the way up to 17. So I'll get you guys to fill out the rest and memorize those. They're really helpful. So 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared, 12 squared, 13 squared, 14 squared, 15 squared, 16 squared. Okay, so you go and fill them out and memorize them. So the square of a number is the resultant that you get when you multiply something by itself. Okay, you probably want to write that down. You can pause the video and go back if you need to. The square root of a number then is the inverse of that. So if I want to get the square root of 25, that is what number multiplied by itself gives that surd, the number under the surd. Okay, now obviously 25 is actually not even a surd, it's just written in exact form as square root 25. A surd is actually a value under the square root sign that cannot be rational. Okay, so for example, square root 17, this cannot be a rational number, it cannot be a positive whole number. It will give you a decimal. So a surd is a number under a square root that cannot be simplified. Probably want to write that down again. A rational number is a number a over b, where obviously b cannot be equal to 0. So it's a number that can be written as a fraction. And generally it can be written as a over b, but b cannot be equal to 0. So a and b have to be integers, whole numbers. An irrational number then is the inverse of that. So this is where we're looking at something like square root 2, okay, or pi. These numbers cannot be written as a fraction, a over b, and normally they give you long decimals. Alright, so evaluating these expressions, these you simply just type into your calculator. So you're literally going to get your calculator out and type in 2.3 squared, and you're going to write down the solution there, okay, for A. For B, you're going to carefully put negative 14 in your bracket squared, and that's going to give you a positive answer because 2 negatives multiply to give a positive. Be very careful in the calculator. If you just type in negative 14 squared, the calculator doesn't actually know what you're supposed to do. So that's going to give you a negative. Okay, so we've got to use our handy brains and remember to place that in brackets, or just also remember that, say you forgot, just think about the reasonableness of your answer, where if you're multiplying a negative by itself, it's going to give a positive answer. And then obviously on the last one, you're doing 3 squared plus 5 squared. We're going to be doing lots of this with our review with Pythagoras. Okay. In question 2, we're looking at, again, evaluate each expression to 2 decimal places. So in this question, we're going to be taking the square root. Now, square root of 256, I know is a whole number, but if they want that to 2 decimal places, we will write that to 16.00. Square root of 98, this is not going to be a simple one. So square root of 98 is going to be 9.899, but they want 2 decimal places. So I've got to think about what that means on my calculator. I can't make it 9.1, that won't make sense. So again, I'm going to round this up to 10.00. The next one, they're just getting you to practice writing in the calculator for Pythagoras. So square root of 4 squared plus 6 squared, and then hit equals. And 2 decimal places here, 7.21. Keep in mind all our rounding rules as normal would apply. So if it's 5, if the number after the point is 5 or more, we round up. If it's not 5, so if it's 4 or less, it stays the same. It doesn't get rounded down, okay? Some people do that mistakenly. All right, question 3 says circle the following surds. Now, a surd is something that cannot be simplified into a rational number or a whole number, okay? So the surds would be this one, not square root 9, square root 24, not square root 81, not square root 225, and square root 15. All those other 3 numbers under the square root sign can be simplified to give a whole number. Okay, so what is Pythagoras' theorem about and how does it work? So we remember from last year that basically you must have a right angle triangle. So for any given right angle triangle, the hypotenuse squared is equal to the sum of the squares of the other 2 sides. In other words, if I were to draw a square on here, pretend that's a square, and a square on here, and I added up the area of these spaces, so these are my areas of these squares, and then that is going to give me the area of the third square. You can imagine that's going to come out here, okay? And the converse of that is also true. So quick revision from year 8 last year. Hypotenuse is the longest side or always opposite the right angle. So in this one, the hypotenuses are. In this one, the hypotenuse is lowercase y or xz. Okay, well, the first thing we started off doing last year was finding the length of the hypotenuse. So to do that, we look at the longest side and we write down x squared is equal to, in this case, 2 squared plus 3 squared. The order of that doesn't matter. I could have done 3 squared plus 2 squared, and I take the square root of that 2 squared plus 3 squared, and that's going to give me my answer. Now, I know that 4 plus 9 is not a square number. It's going to give me the square root of 13. So I'm actually just going to leave it like that in exact form or surd form. We call this surd form or exact form because the minute I type it in my calculator, it becomes more inaccurate. So I leave it like that. In question 3, you'll see that the answer asks you to leave it in surd form. So you're going to do the exact same thing, but again, you're not going to type in your calculator. So here, x is equal to the square root of 2 squared plus square root 10 squared. And that's going to give me the square root of 4 plus 10 because the square root and square cancels out. And again, that's going to give me the square root of 14 centimeters. And that's what x is. You notice I skipped this first step there. That's fine to do. Question 4, find the value of the pronumeral to 2 significant figures. Again, I'm finding the hypotenuse. So x is equal to the square root of 13 squared plus 8 squared. And I can simply just type this into my calculator. Square root of 13 squared plus 8 squared, and that's going to give me 15.264, but they want 2 significant figures, so we've got to think back on our previous work, and to 2 significant figures, that's actually just going to be 15, because I'm just looking at the first 2 important numbers. So write down your own summary. So we've just kind of revised today the meaning of Pythagoras' theorem, the meaning of squares, square roots, surds, rational and irrational numbers, calculator work, what Pythagoras' theorem is, how to identify the hypotenuse, and how to find the value of the hypotenuse, either in surd form, rounding, or to significant figures. Please feel free to let me know if you have any questions. Give me an email. You're practicing questions of your own now from the text exercise here, 3A. Thanks, everyone.